Hi there. My name is Kavan. I'm a lecturer in physics and astronomy at Monash University. And I teach first year and second year electromagnetism. And today I'm going to demonstrate the jumping ring experiment, which is an application of Faraday's law and Lenz's law. So what I've got down here is a solenoid, which is just a wire wrapped around many times in a loop, and that's connected to an electric outlet. And when I press the button, a current will flow through it. Now to show you that a current really does flow through it, I've got another solenoid that I'm going to place here, and that solenoid has an LED attached to it. And that LED will go off, indicating that a current's going through the bottom solenoid. So there it is. The two LEDs have gone off. Now, what happens is when a current runs through the solenoid, it induces magnetic field, which is initially 0, and then it increases. As it increases, the second ring, which is not attached to the solenoid, there's a rubber ring here to isolate them electrically from each other. This other ring will see that change in magnetic field and will want to resist it. And in order to resist the magnetic field, it will induce a current in the opposite direction, which will induce a magnetic field in the opposite direction. So it will be very much like bringing two magnets of the same polarity towards each other. They're going to repel each other. And that repulsive force is going to act out, and this thing's going to go flying. So now how high it flies depends on the mass of the ring as well as its conductivity. So here's another material which flies much higher. Now what happens if we put a little slit in a ring? So I hope you can see a little slit. So what that means is the circuit isn't closed, and in that case, when I press the button, no current flows through it and nothing happens. So it's quite boring. However, we can do something fun with that. Let's take a closed ring and a bunch of open rings, and let's put them together. It's a nice and heavy one. We'll avoid that. A couple of more. Ooh. The jump is a little bit lower because we only have one loop that is generating the force, and the rest of them are just weighing it down. Let's put a few more in. Still quite heavy. And here we go. We get a nice hovering experiment. And that's because as the magnetic field is changing, there is a force that is making the rings go up, and then when the circuit goes off, the magnetic field is changing in the opposite direction, and it induces another force that's going on, and so we get a little bit of hovering. So the height to which the ring rises, or the magnitude of the force between this solenoid and the ring, depends on the mass of the ring that's on the top, as well as its conductivity. So one thing we can do is increase the conductivity of the ring, and that can be done by cooling it. And so I've got some liquid nitrogen here. I've got to put some gloves on because liquid nitrogen is very cold, and if I don't put gloves on, I'll burn my hands nicely. So I've got this ring that's been cooled in liquid nitrogen, and I'm going to put that on here. So it's the same ring as the silver ring that I've used before. And now let's see what happens. Goes way up. Might have damaged the ceiling. So by increasing the conductivity, the current that's going through the ring is higher, and therefore the magnetic field that it induces is much higher. Therefore, it's a much higher repulsive force.